Hello, my name is Connelly, and this is my custom program. It is a 3D engine made almost entirely out of Swingame. The other module which was used was ixmelee.stl from the Visual Studio package store. This is what I use to import my STL files that I've designed in Blender. My original plan for this program was to basically recreate my last semester's program. However, I was eventually convinced to make some sort of simple 3D Doom-like game. To simulate a 3D world, I initially thought about making a weird sliding bitmap mechanic or a bazillion raycast system for every single pixel on the screen, but those were both stupid ideas. Eventually I figured out that creating vectors from the camera to each vertex in a mesh and calculating the delta angle from the camera direction was the correct way to do this. Capabilities of this program include the ability to see entities in 3D space with visual components inside them, the ability to import meshes from STL files, the ability to apply dynamic lighting with a diffuse amount, and different brightness. And you could also do static lighting by applying a lighting lock onto a entity. And this will increase processing ability. Mesh rotation is also possible, but only in the your direction, because I'm not good enough at vector math. Something that's cool, you could also do raycasting onto a hitbox like that, and you could also use it for hitboxes for collisions. One thing that's cool is that you could use lower alpha colors onto your meshes to create transparent meshes like this. And you could also put this entire engine into a DLL like I did, and I use it for my custom projects, and made a tutorial on it, how to make this. This program is structured by having a 3D world in which contains 3D game objects, game object 3Ds, which hold a reference to the world, the position, direction as a vector 3 using my vector 3 class. It has tags for identification. There are three basic classes that inherit from this, being the light source 3D, the camera 3D, and the entity 3D. The entity 3D holds the mesh 3D, which holds a number of visual components which are abstract and can be either a sprite 3D, which draws a bitmap, a triangle 3D, which is used in my meshes, and a line 3D, which is used for drawing lines. Each of these are picked up by the camera and the camera 3D class and draw themselves based on data set by the camera and their type. The biggest problem that still exists is backwarping, in which if a triangle has two vertices that span a pitch or yaw between 180 and negative 180, or an entity has verges that span a pixel from 180 to negative 180, meaning that's behind the camera, it is mapped to opposite sides of the canvas of the screen. So if I move my camera right up next to the sword, the tip of the sword is actually right behind me, but if I move from left to right, I can make the sword snap all the way from one side of the screen to the other, because it is flipping from a yaw of 180 to negative 180, which is mapped to really far to the left beyond the screen size, and really far to the right beyond the screen size. The only solution was mitigation by making either entities or the actual components unrendered at certain angles, which is the field of entity render and component render. This was a bit fiddly because large triangles had to be were sometimes unrendered when they really should be rendered. And the result is that the only real solution is to use lots of small triangles, which actually contributes to another program or another issue of processing and frame rate loss. The biggest thing that I can prove on this project is to use a struct for my vector3 instead of a class, because structs generally are faster and work on the stack, although I couldn't use it as a reference or as